Hi, my name's Ewan Bowie, and this is my technical audio design showreel where I've compiled a multitude of audio systems that I've used throughout game audio projects. So to start off with, we have an audio spline system, which acts as a railroad for the audio source to run along on. So it tracks the player's current position and movement, and instead of having multiple audio sources throughout the map, we can have one, saving resources. So it utilises the inbuilt spline component within Unreal, and with this, we can place the audio source into the spline. So then it tracks the player's kind of position and movement speed with its own snapping speed, so how quickly it can snap to the player's current position, how natural you want it to sound, kind of different variables and parameters that are interchangeable, whilst updating its own initial position, getting rid of old inputs that are no longer required. This is a mastering toolset plugin I've created for Unreal Engine 5. It just lets you audition the sounds in your game at the end of the mixing process so you can master them accordingly for each playback system or for your own desire. It compiles of a submix selection box which takes all the submixes created in your game or your specific sounds that you've specified and fires them into the plugin. It's essentially a giant DSP board that lets you analyse and process the sounds coming into your game using tools such as EQ, compression and limiting. But say if we wanted to isolate certain reverberation sounds, so we can increase the sort of higher end to see how these might resonate around the room. And then we can adjust them accordingly, adding certain compression values and also decreasing certain volume factors. So that is the toolset. It was built using MetaSounds blueprints and C++ with Visual Studio. I used Engine 5.1 for this example. This is a free-thinking reverb system which measures the distance between the player and adjacent walls or objects, measuring the average room volume of the occupied space. So I've used 4 beams here that utilise line tracing, which shoot out and measure impact points from the players to the positioned walls, and then stores these impact points within an array and takes the average measurement of these 4 impacts to get the overall volume of the room. Feeding this into Wise, we can now create a reverb system which automatically adjusts itself to the acquired space within the player's context. Using ambisonic recordings taken from fieldwork, I've placed these into Fmod and linked them to a continuous parameter. This then powers the volume of each track, which is linked to the car's velocity within a racing game, creating an immersive ambience as the car accelerates. Here we have an example of generative synthesis using Unreal blueprints. This just allows the possibility to create a variety of different synthetic sources throughout a project. Here is a granular synthesis system used in Max MSP, using both an onload and offload system, both identical to each other, and is dictated by a slider control to choose a percentage of each. Each has an overall volume control for the recordings of the engine from low, mid to high, splitting it into a corresponding frequency bracket and using a buffer to intake the wave file. Inside each frequency bracket is an overall volume control and a gain control for a sine oscillator and a fixed oscillator feeding into a phaser. The phaser line splits the MS into frequency to decipher the pulse feeding into the buffer control, which selects the time position of each grain in the wave file. Down the middle is a cycle oscillator which acts as a foundation, creating a solid tone which builds upon the grains to sound more natural. Down the left here is a scale insurance system which just ensures that all the frequency brackets are corresponding to the same volume factor. And at the very bottom is some graphs to give a visible representation of the signals or the grains that are used, just giving more context to the selective positions and timings of each grain, and this is shared throughout the kind of output of each frequency band. So this system can then be inserted into any game engine using OSC messaging, and for an example here I've got a redesign of an airplane engine and an implementation in Unreal as a car engine.